Yes, great question. There's always limits of physics. I think famously Elon Musk had said, for better or worse, there's a lot of laws that can be broken, except physics. You cannot break the laws of physics or you will have severe consequences instantly. And so there are limitations on the performance. The good news is that the components will improve every year. And so the transducers is really a key. If I had to pick one device where I think there's the biggest progress that needs to be made in the next couple of years to integrate quantum compute into classical compute in a data center, it's really that transducer. Where you're converting from the frequency of the qubit into the frequency of the optical photon that's providing the entanglement-based network. The efficiencies I mentioned for superconducting are quite low. We want to see really closing that gap in that efficiency, because for scalability and speed, superconducting quantum processors offer a lot of benefits. They have the highest repetition rates, the scalability through fabrication and stability, like the qubits stay where they are. With neutral atoms like QEra, it's really exciting to see their progress. They've said that they have a number of tens of logical qubits, which is awesome to see. But the way they do their gates, the way they do computation, they have to shuttle the atoms around, and that is a slower process. And so for speed and lithography scaling, superconducting quantum computers have a lot of advantage, but they're the hardest to do the transduction. So I'd say the one area where I think the physics, we need to really work hard, because it's challenging to convert those qubit states into the photon states in the fiber. That would be one of the most important limitations for us. And then it's around the distance. So the good news is we don't need a quantum repeater to do the cluster networking in a data center today. You're far less than 20 kilometers limit in a fiber without a repeater. Once you want to go beyond 20 kilometers to 50 or 100 or more in fiber, you're going to need to use a quantum repeater. So looking further down the road for distributed quantum computing, you're going to need to have that repeater. But the great news is in the next few years, we have the infrastructure we need, we have the devices we need, the performance is good enough that we can do a basic QPU network. And that's what I'm super excited to see.